we need to find the force exerted on the spring AE and the spring DG based off of the input forces of P and Q. So I drew out the free body diagram here, and we're told by the problem that AE, BF, and DG are parallel. So you know that the angle theta amongst the three of them are all equal to each other. And I also written out the cosine of theta and also the sine of theta, which will help us find the required moments and the required forces. So to start with, we're going to first find the force exerted on the spring AE. So we're going to write that the sum of moments about a point B is equal to 0. And we can write that as the force on AE times the cosine of theta times 150 minus the force P times 600 is equal to 0. So we plug in the known terms. So we have the force AE times 4 over 5 times 150 minus 160 times 600 is equal to 0. And solving this equation for F of AE, we get a force of 800 newtons. So next we're going to find the force exerted on the spring DG. And to do that, we're going to first find the forces, the component of the forces that are exerted at the point B. And then we use that information to find the force on DG. So we'll start by saying that the sum of forces in the x direction is equal to 0. And that's going to be equal to negative f of AE times the sine of theta plus the x component of the force at point B minus the Q input force. And we set that equal to 0. So we plug in the known terms and solve for B of x. So we get negative 800 times 3 over 5 plus B of x minus 80 is equal to 0. And solving this equation for B of x, we get a force of 560 newtons. So we now do the same thing for the y direction. So we have the sum of forces in the y direction is equal to 0. And we can write this equation as negative f of AE times the cosine of theta plus B of y minus P is equal to 0. And we plug in the known terms. So we have negative 800 times 4 over 5 plus B of y minus 160 is equal to 0. And solving for the unknown term, B of y, we will get a force of 800 newtons. So we can now take the moments, the sum of moments about the point F. So the sum of moments about the point F is equal to 0, which we can write as E of x times 400 minus B of y times 300 minus F of dg times the cosine of theta times 200 is equal to 0. So now we plug in the known terms and solve for the unknown F of dg. So we now have 560 times 400 minus 800 times 300 minus the unknown force F of dg times 4 over 5 times 200 is equal to 0. And solving for the unknown force, we will get a value of 100 newtons.